Hi, welcome back. So today we're gonna talk about 2.4, the derivative formula for the product rule and the quotient rule. These rules are very essential, very important when we're trying to find the derivative of functions. And we're gonna see the benefit of using these rules from not using them before, right? And so let's jump in with the first one. In the first example, we're just gonna go through an example of what would look like if we didn't use the product rule to find the derivative of the function. So in this section, we're adding the two more rules to our derivative rules table, the product and the quotient rule that allow us to find the derivative of functions that are product of two or more functions and the quotient of two or more functions, so respectively. So we're going to talk about the rule in a second, but first let's just go through this problem that it does not that we're not going to use the product rule, right? And the product rule is often used, right, whenever you have a product of a function times the product of another function, right? So this would have been a perfect example of using the product rule. But again, let's just go through the motions of not using it just to see how this will be different than when we actually have to use it or when we actually use it. So let's go ahead and jump in. So to be able to find the derivative of this, we would have to actually rewrite the problem and expand it. So let me go ahead and right. So we would have to do this, right? Expanding distribution, right? So we haven't done the derivative. We're just expanding this. So this will be 7x minus 8x to the third minus 28x cubed plus 32x to the fifth. All right. So we would combine these two together. We would have 7x minus 36x to the third plus 32x to the fifth. All right, so this is the original function, right? Now we would now we would take the derivative of this. So we'll take the derivative by using the power rule. So we have 7. So this one, right? Remember the x will go away. So we have x times 1, or 7 times 1, minus 36 times the derivative of x cubed is 3x squared, plus 32 times the derivative of x to the fifth, which is 5 times x to the fourth, right? And then we would simplify this. 7 minus 108 x squared plus 160 x to the fourth. So here is an example of finding the derivative of the function without using the product rule. Right. So we'll come back to this one later on, just to compare it to when we actually use the product rule. So what is the product rule? So we assume that the function f and another function g are two differentiable functions. That means you can take the derivative of both of them. And if you're trying to take the derivative of the product of these two, what we would do is follow this special formula. Now I have to say that this formula was not it just didn't appear or was just invented out of nothing. This actually came out from using by using the limit definition from 2.1, right? That long one, the long definition of the derivative. You can use that to actually find this general formula, right? That's what it will come. Of course, we're not gonna go through that, but you could generate from there, right? So the suggestion is for us to actually memorize this formula. We're gonna be using it tons, 101 times in here, or 1,001 times. So we prefer if you memorize this formula. So what this is saying is you have this function multiplied by this function, right? The first function versus the second function. It's a product, right? So what we're saying is you're gonna take the derivative of the first one, right? Multiply by the second function without the derivative, followed by a plus. And now what you're gonna do is you're gonna change the order who is gonna take the derivative, right? Now the first function is gonna stay original, and the second function will take the derivative. So all we're doing is using the same product, and then pretty much you alternate who has the derivative, right? So you kind of like copy and paste it twice, right? One where this is the derivative, and then the other one where the other one's derivative. Don't forget that this is a plus. And that's pretty much it, right? So if we say this out loud, so it's the derivative of the first factor times the second left alone plus the first left alone times the derivative of the second one. And here's another way we can see it, right? Sometimes we would write it this way just because it's easier for us to write it. So it will be the first, the second, the derivative of the product, right? And so the derivative of the first factor times the second one left alone plus the second one, the first one left alone times the derivative of the second one. So and that's pretty much what we want to do. Um, and of course we can extend this. So what would be wrong, right? What would be a big wrong, common mistake, right? So here I'm going to say warning, right? Warning. I don't know why I put the wrong one, but the wrong thing to do is to think that this is kind of like the summation one. Will be wrong for us to do, very very wrong, and which is very very common for students will to make this mistake, is to think, oh, the derivative of this is the derivative of the first one times the derivative of the second one. No, 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 right? No, so that's not correct. Very common mistake. Please, please, please know that the product rule is there for a reason whenever you have a product of two functions, right? So be careful. Now we can extend this product rule so that when we have more than two factors, right, two functions, and the pattern just continues, right? So here, let's pretend that we have three functions that are being multiplied. So you're gonna take the derivative of the first function times the second one times the third one left alone, right? So these are left alone, plus the first one left alone times the derivative of the second one times the third one left alone, plus the first one left alone, the second one left alone times the derivative of the third one. So you guys see the pattern here? All we're doing is copy and pasting this 3 times and taking the derivative, and we alternate the derivatives, right? And that's how we interpret this rule. So let's jump into to the first example. It's the same example as we did before, that we did in the beginning, but this time we're gonna actually do the derivative finding using the product rule. So here, let's rewrite the function. And what I'm gonna suggest here is that you actually set up the function, right? And maybe just write down the product here, just so you remember, right? Just so you remember. So I'm gonna follow that, and I'm gonna do this, but I'm gonna go ahead and set it up. I'm just gonna go ahead and put some brackets and say I'm gonna take the derivative of this times the second one left alone plus the first one left alone times the derivative of the second one. The reason why I choose to show you this way is because a lot of times students they want to do everything in their head, and they, especially when they're trying to get used to this, they will make silly mistakes, or they won't be able to visualize the real application or the right way to do this, right? And they'll get lost very very quickly. I can do it in my head, but that's because I already have so many years of practice, right? So I'm gonna go ahead and do it the way I'm showing you, because I think you guys will benefit more. So let's go ahead and jump in. And now that we have set it up, this is technically the derivative, but now we have to just execute these two derivatives, right? So we're gonna take the derivative of that. The derivative of x is 1. the derivative of minus 4x cubed is 4 times 3x squared. Now, when you take the derivative of a function, you have to remember that was part of a group. So it stays as a group after you take the derivative. So I'm going to go ahead and keep those parentheses surrounding that derivative that I just found. Now I'm going to take the derivative of the second one, and the derivative of that will be this derivative of 7 is 0, and the derivative of negative 8 times x squared will be negative 8 times 2x. So again, I'm going to surround parentheses, I'm going to put parentheses around that one, and just to remind you that that's supposed to be grouped. And I'm going to go ahead and simplify this. Negative 4 times 3 is 12. This carries over. And this is going to be negative 16x. And so this is technically the answer right here. This is as far as I want you guys to go, right? This is it. Right? This is your answer. You can leave it in a factor form. I almost forgot to put a parenthesis there. This is it, right? That's your derivative. You already used the product rule, and you already executed the small derivatives, right, of the factors. So this is it. But let me just go ahead and continue just to show you that this would have given you the same answer as above. So if you would have distributed these two numbers, this would have been 7 minus 8x squared minus, I'm just using distribution for the first one. For the first product, and the second product would be right. Of course I'm just speeding this up, but this would give us 7 minus 108 x squared plus 160 x to the 4. And so this, if you compare, this is the same as the same answer as above, right? So we end up getting the same answer. But again, this is okay with us. Just leave it in here. There's no need for you to continue with this distribution. Anyway, so that's pretty much it for this problem using the product rule. I'm going to stop the video here and I'm going to continue with the next one in